Now I'm going to work example 1B by using the fundamental identities to solve this question. Okay, so again, we know that the tangent of theta is equal to negative square root of 7 divided by 2, and that the secant of theta is greater than 0, and our goal is to find the remaining 5 trigonometric functions of theta. Okay, we already know tangent of theta, that is given. It is negative square root of 7 divided by 2, but we need the other 5. Okay, so let's get started. When I worked this problem before by drawing a triangle, the first thing we did was establish the quadrant that theta is in. Again, we don't know the exact value of theta, but we can tell the quadrant that it is in. We said this is happening in quadrant 4 because here the tangent is negative and the secant is positive, and so that combination occurs in quadrant 4. Okay, so we need that information to get the signs of our trigonometric functions correct, meaning plus or minus. Okay, all right, so let's start getting our trigonometric functions. Okay, the easiest one to start with is the one directly related to tangent. Tangent is given, so we're going to be able to get cotangent of theta from this. Okay, the cotangent of theta is going to be 1 over the tangent of theta. We're going to use that reciprocal identity here. Okay, and so this is going to tell us that the cotangent of theta is going to be 1 over negative square root of 7 divided by 2. Okay, so this is going to be 1 over 1 over negative square root of 7 over 2. So we are dividing fractions, so we'll leave the top fraction alone, change to multiplication, flip the bottom fraction, multiply across the top and across the bottom. This is going to give us negative 2 over the square root of 7. We need to rationalize the denominator. So multiply top and bottom by the square root of 7. So if we multiply across the top, we're going to get negative 2 times the square root of 7. The square root of 7 times the square root of 7 is 7. Okay, so there is your cotangent value. Okay, so we're going to come down here and write it in. It is negative 2 times the square root of 7 over 7. Leave all the answers as exact values. Okay, moving on. We still need sine, cosecant, cosine, and secant. So it doesn't matter which one you start with, but you want to be able to use an identity that's going to require you to plug in a value that you already know. Okay, so we know tangent, we know cotangent at this point. So the next thing I'm going to try to find, I guess, is since I know the tangent, I can use 1 plus tangent squared theta to get secant squared theta. Okay, so if I use this identity, I can find the secant. Okay, again, there's more than one way to do this. You don't have to go with secant next. It's up to you. Okay, but this is what is going through my head right now. Okay, all right, so here we go. Again, you want to interpret this. This is 1 plus the tangent of theta squared. That's got to be equal to the secant of theta squared. I know the tangent of theta. I can go ahead and plug that in. The tangent of theta is negative square root of 7 over 2. So we're going to get 1 plus negative square root of 7 divided by 2. We need to square that quantity. That is going to be equal to the secant of theta squared. All right, so if we simplify this, this is going to be 1 plus, we need to multiply negative square root of 7 over 2 by itself. The negative is getting squared, so negative times negative will turn positive. This is a fraction squared, so we square the numerator and the denominator. The square root of 7 times the square root of 7 is 7. That will be in the numerator. And then 2 squared is 4. Okay, and again, this has to equal the secant of theta squared. All right, so now if I do the work over here, to turn this into a single fraction. So I'm just going to add these two guys together. So I'm going to make this a fraction. Okay, and put it over 1. I need a common denominator. Okay, that's going to be 4. So this first fraction, 1 over 1, I need to convert it to a fraction over 4. So I'm going to multiply the top and the bottom by 4. So we will have 4 in the numerator. 4 divided by 4 gives us the original 1 plus 7. Okay, that's equal to the secant of theta squared. Okay, so we know that the secant of theta squared, which is secant squared theta, that is equal to 11 over 4. Okay, and now we want to solve for the secant of theta. So since it's squared, we're going to take the square root of both sides. On the number piece, we need to put a plus or minus out front. And so on the right, the square and the square root will cancel, leaving you with the secant of theta. On the other side, you're going to have plus or minus. You have a fraction that you're taking the square root of. So this is going to be the square root of the top over the square root of the bottom. Okay, and luckily we don't have to rationalize here because we know the square root of 4. This is going to be plus or minus the square root of 11 over 2. Okay, so at this point we have two options for the secant. We have a positive version and we have a negative version. Okay, but one of the stipulations in the problem was that the secant value has to be positive. Okay, so we need to choose the positive one, and I'll write that out here. So we're going to choose the positive square root of 11 over 2 because we are told that the secant of theta has to be greater than 0. Okay, so I'm going to go ahead and write that in. Okay, the secant of theta is going to be the positive square root of 11 over 2. Okay, also we are in quadrant 4. In quadrant 4, secant and cosine are positive. Okay, all right, so now that we know secant, we can get the cosine. Okay, so I'm going to come out to the side over here. I'll use a different color. So now I want the cosine of theta. That is just going to be 1 over the secant. Okay, you just have to flip the secant value. All right, so this is going to be 1 over the cosine, or sorry, the secant value is the square root of 11 over 2. Okay, so let's flip this. Okay, so this is going to be 1 over 1 over the square root of 11 over 2. So leave the top fraction alone, change the multiplication, flip the bottom. Okay, that is going to give me 2 over the square root of 11. I need to rationalize the denominator, multiply both the top and the bottom by the square root of 11, and then multiply across the top and across the bottom. We're going to get 2 square root of 11 over the square root of 11 times the square root of 11 is 11. Okay, so the cosine value is 2 square root of 11 over 11. Okay. All right, so that leaves us with the calculation for the sine and the cosecant. Okay, so at this point you have several options in terms of where you want to go from here. I know that, well, I just figured out the cosine, and I could use the Pythagorean identity here that sine squared theta plus cosine squared theta is equal to 1. Okay, so that might be a way of doing this. Okay, but again, if you want to use a different identity, that's fine. Okay, I'll just use the Pythagorean identity here. So I know that sine squared theta plus the cosine squared of theta has to be equal to 1. Okay, I'm after the sine value, so I'm going to solve this for the sine squared of theta. So I'm going to move the sine squared of theta to the other side. So sine squared theta is equal to 1 minus the cosine squared of theta. All right, so now I can plug in for the cosine value. Okay, remember this is telling us that the sine, well, let me write it this way. And again, you don't have to write it this way. I'm just trying to clarify so that everyone understands. This left side means if you take the sine of theta, that value, and square it, this is going to be equal to 1 minus the cosine of theta, that value squared. Okay, so at this point, to get the sine of theta squared, I'm going to take 1 and subtract the cosine value. The cosine value is 2 square root of 11 over 11. Okay, so this is the quantity that I need to square. Okay, and simplify. Okay, so this is going to be 1 minus, we are squaring a fraction, so square the numerator and the denominator here. Okay, so 2 squared is 4. We've got to multiply that by the square root of 11 squared, that's 11. The bottom is 11 squared, which is 121. So I'll just go to the calculator for this one. I'm going to do 1 minus 4 times 11 over 121. Okay, that's going to give me a nasty decimal. I'll convert it to a fraction. I get 7 over 11. Okay, so I'll just keep going here. So now this tells me that the sine of theta, that quantity squared, is equal to 7 over 11. All right, so to undo the square, I'm going to take the square root of both sides, put a plus or minus out front. Okay, so on the left, the square and the square root cancel, leaving us with sine of theta. On the right, I've got plus or minus the square root of a fraction, so take the square root of the top over the square root of the bottom. I need to rationalize the denominator. Okay, so this is going to be, let's see here, this is going to be plus or minus, I'll worry about the sign after, square root of 7 over the square root of 11, multiply the top and the bottom by the square root of 11. Okay, so this is going to be plus or minus, multiply across the top, square root of 7 times the square root of 11 is the square root of 77. The bottom, the square root of 11 times the square root of 11 is 11. Okay, so that's our sign value, but now we have to choose between the plus and the minus. Okay, and since we are in quadrant 4, you have positive x values and negative y values. The sign is associated with the y value, which is negative here. Okay, so we need to choose the negative option. Okay, so I'm going to put right here, choose negative because we are in quadrant 4. Okay, so the sine of theta is going to be equal to the negative square root of 77 divided by 11. Okay, all right, so now we just need to get the cosecant of theta. Okay, let's see if I can fit that somewhere. I'll put it up here. Okay, so the cosecant of theta, so this is my fifth and final trig function that I need to calculate. That's just going to be 1 over the sine value. Okay, so let's plug this in. 1 over, we just calculated the sine value to be negative square root of 77 over 11. Okay, so this is going to be 1 times, we're dividing fractions here, this is going to be 1 times negative 11 over the square root of 77. Okay, so negative 11 over the square root of 77. Let's rationalize here. Okay, multiply across the top and multiply across the bottom. This is going to be negative 11 times the square root of 77 over 77, but we can reduce. 11 goes into 11 once. It goes into 77 7 times. So the final answer for cosecant is negative square root of 77 over 7. Okay, so I'm going to go ahead and write that in. Okay, and we have all 6 of our trigonometric functions. They are all exact values. Our signs are good, meaning that we're in quadrant 4. Only the cosine and the secant should be positive. Okay, I'm going to go back and compare these answers to what I got when I worked the same problem by drawing a right triangle. Okay, that was back on page 4 here. Okay, so if we compare our answers here, I'm going to start by comparing my sine and my cosecant. Okay, those guys match. Okay, and then I'm going to compare my cosine and my secant. Okay, those guys match as well. And then lastly, I'm going to look at my tangent and my cotangent. If I kind of toggle between the two, again, I have a match. Okay, so again, when you're working a problem like this, it's up to you. If you like drawing the triangle, do that. If you like working with the identities, do it that way.